So I thought I'd talk again, instead of just posting, writing, about what an Einstein vector tensor field is, and what I'm talking about that we can use to enhance the Einstein vector tensor field, which is taking what he has done, which was fantastic, and enhancing it to something called a quantum state vector tensor field. So imagine you're looking at like a piece of graph paper. In the middle of each little square there's an arrow, a little vector, and the direction that those vectors are pointing, that is describing the curvature of space-time at that point, or the gravitation, or the gravity. What quantum information holography is showing is that we can take the angle of each one of those vectors and use it to describe curvature, was what Einstein was doing. But we can also use those vectors if we see them as entangled bits of Hawking radiation emitted from black holes. Then they become what's called a quantum state vector, where the cosine of the angle of that little bit of Hawking radiation, that little bit of quantum light that is emitted at that point, the cosine of it tells you the percentage of the speed of light that is encoded as velocity. And so you have a little angle there, and that angle tells you the velocity encoded as a percentage of the speed of light. The angle of that quantum state vector, when you take its cosine squared, that gives you the probability that that little qubit will be in a spin up or a spin down state. That's like the pixel being on or off, a 0 or 1 in a computer. And then the rate that that quantum state vector changes is the rate of change of velocity, because velocity was encoded by just the angle. And the definition of acceleration is the rate of change of velocity. So the rate of change, how fast those quantum state vectors spin, that encodes acceleration. And acceleration, as Einstein proved, is equivalent to gravity. So we can show now that if these are entangled black holes, like it appears to be, then his vector tensor field actually becomes a quantum state vector tensor field and describes gravity, velocity, acceleration, and probability. That is what unifies and bridges quantum mechanics and relativity. He understood it perfectly well, but he didn't know what quantum computers were, or he would have found it. So it's beautiful, it's simple, it becomes complex, but it's been sitting right in front of us this whole time. So I hope that helps a little bit in understanding it.